Okay, so today's February 23rd. You have a test tomorrow or whenever we next meet. For those of you who aren't here, when you walk in, you'll be taking the test. So if we have school tomorrow, it will be tomorrow. Ooh, something really stinks.
That'd be me.
Oh, okay. Anyway, here's what's on your test. Your test has one large free response question involving exponential growth and decay. It's multiple parts. It's 4 parts. It's worth 30 points.
Are you going to do a sample?
Yes. That's what today is for.
One large FRQ.
With a side of fries.
Yes.
Exponential
Growth and decay.
growth and decay.
Multiple parts.
Multiple parts.
30 points.
Does the test have a 100?
Yes.
Oh, no. Side of like a million.
Okay. The next part will be a large free response question involving slope fields. Very similar to what you saw in your quiz, with a couple of additional parts that you won't have seen before that we will go over today. Very easy. The slope fields question is worth 38 points.
It's larger.
I feel like it's just going to be 3 questions.
Yeah, each question gets 10 points.
Okay, so the first 2 questions are worth 68 points.
That's almost a failing grade. Actually, it is a failing grade.
That's almost a passing grade, right?
Oh, true.
Okay, now, there are 5 multiple choice problems worth 5 points each. The multiple choice problems involve the following concepts. They involve integrals, where the solutions are natural logs. They involve the integral of all 6 trig functions. They involve the integrals where the answers are inverse trig functions, arcsine, arctan, arcsecant. Integrals of e to the x. Integrals of a to the x. And matching a slope field to a differential equation.
Alright, that's 6 options.
There are going to be 6 multiple choice questions.
No, there's 5.
Wait, what was the last one?
Matching a slope field to its differential equation.
So which one's not?
Similar to what was on your quiz.
So which one's actually not on the test? Because that's 6, and you said there are 5.
Maybe we did a combo problem.
What? You can't do that. That's cheating.
I mean, you can.
There is also a joke. It's a
Alright.
long joke. It's worth reading. I like the joke. Some people don't think
I
it's
hope
that
it's like a joke where
funny.
you have to like stand up and I do the cha-cha.
No, it's an actual joke. I think it's very funny.
I read the longest joke.
So-
It's like 15 minutes to read.
Oh, this one won't take you that long. And it's only worth a point. Now, if you sum the total of all of those points up, you don't get 100.
Is it not a
You get 94.
Are we getting 9, 5,
6 points?
6 extra points?
If you leave the whole test blank, you get 6 points.
Awesome sauce.
Right? Yes. Yes. So you've got 6 free points.
Did you
Right
write this
now.
test?
Has
I
anyone
did.
ever like
I like
tested
the
that out?
joke is worth
Okay.
7 points.
The joke is only worth 1 point. Well, technically, if you get the joke right, you've got a 7.
Yeah.
Even if you get nothing else right.
So that means the joke is worth 7 points.
Technically, if you want to
Joke
go
really
that far.
hard.
Is there like even a question?
Is the joke hard? No.
Is there
How much do I
Like
talk
yes or
yes or
no.
no?
It's yes or no.
It's so
You
burst
you
out
laugh.
laughing.
You said it's like 8 and 12.
So,
No, I.
Yeah, what if I
I
laugh?
thought it was going to be
too
like one of
hard?
those confusing riddles that I was never going to get.
What if the
No,
joke?
you don't have to do the answer to the joke. The answer is given.
What if the answer to the joke is so funny I burst out laughing? And I just can't control myself.
Well, let's try to control our laughter.
I'm gonna wait till the end to do it, and then I'm gonna be.
Okay. There is a bonus. Yes, there is a bonus. Okay?
So you
So-
can technically get 100 and with this
105.
for 5 points.
All right, so here's what we're going to do. We're going to start with a free response question.
Let's start with the log/decay point. That or long exponential growth/decay. That's worth approximately 30 points.
That's a good place to start. Okay,
Well,
so
isn't
I'm on
it
your review sheet that you all got on Thursday with your sub. You
She
guys,
was very friendly.
good.
Yeah, she was nicer than she usually
He
is.
didn't say
Oh,
anything, it
good.
was
That's
great.
nice.
Yeah, she was just
Okay.
silent.
That's wonderful.
All
right.
That's because I duct taped her lip shut.
So the first problem on the free response review talks about oil being pumped continuously from a certain oil well at a rate proportional to the amount of oil left in the well. That is dy dt equals ky, where y is the amount of oil left in the well at any time t. Initially there are 1 million gallons of oil, 6 years later there are 500,000 gallons.
That is not a lot of oil, just when you think about it. They are pumping nothing out
They're not pumping a lot, no. Okay, just like on your test, the differential equation is given to you. It is also given to you on your test. So you don't have to write your own from scratch, it'll be there.
That's nice.
Alright, the part A on this review is actually parts A and B on your test. So part A on this review is actually 20 points of your test. So here we go. Let's do part A.
Alright, let's learn how to do this for sure.
Okay, so you all got your quizzes back. You guys did very well on your quizzes as far as solving differential equations. I mean, overwhelmingly, most people know how to do this and know how to do it well. So you have dy dt equals ky. What's the first thing we do?
Divide by y and multiply by e.
Beautiful. We have to separate the variables. So we get 1 over y dy equals k dt.
Integrate.
Integrate both sides. Antiderivative 1 over y,
Y absolute value.
ln y. And for this problem, I don't have to put an absolute value. Why not?
Because you can't have
It represents the amount of oil in the well. On the antiderivative of k dt, kt plus c. If you are forgetting to write the plus c with your differential equations, please stop forgetting that, because that's going to cost you more than just a couple of points. It'll cost you quite a few.
What, plus C?
Yeah,
Oh, yeah, that's important.
that's very important. All right, so you get that. Now we have to solve for y, so I'm going to exponentiate both sides. We get y is e to the kt plus c, which I'm going to call ae to the kt. All right, any questions on that? That would be equivalent to part A on your test, so that would be the first 10 points. The next 10 points would be plugging in the information given to find the values of the unknown constants, right? So
3 points.
we are told initially there's 1 million gallons of oil in the well. So when t equals 0, our y is 1 million.
That's a lot of zeros.
And when t equals 6, our y is 500,000. So I'm going to plug in the t equals 0 amount first. So I have 1 million equals a e to the 0, which is just a. So a is 1 million. So we have y equals 1 million e to the kt. Now I need to find k. So now we plug in the other information that's given. So 6 years later, there's 500,000 gallons. So we have 500,000 equals 1 million, whoops, e to the 6k, because t is 6. When you divide, you get 1/2 equals e to the 6k. A couple people, not too many, maybe a couple, took natural logs here. You have to get the e by itself first before you take the natural log of both sides. Otherwise, you can't cancel it properly. So now we take the natural log of both sides. We get ln of 1/2 equals 6k, and k is 1/6 times the natural log of 1/2. Any questions on finding A or K? So our final function, I'm still on part A because it said we have to write an equation for y. So our final function would be y equals 1 million e to the 1/6 ln of a half times t.
Swag.
All right, everyone feel fairly confident with that? Okay, good, because that's the first 20 points on your test, right? Okay. Now, on this review, part B, this is not on your test. I'll show you how to do it real quick. It's kind of fun. It's a little bit of a trick. This is actually an old AP exam question. So they said, at what rate is the amount of oil in the well decreasing when there are 600,000 gallons of oil remaining? So we know y is 600,000, and we want to find the rate. What represents a rate?
dy dt equals
The
ky.
derivative, the dy dt, right? So we're looking for dy dt.
Equals ky.
Hey, we have a formula for dy dt.
Hooray.
dy dt equals k, which is 1/6 ln of a half, times y, which in this problem is 600,000.
Isn't that just wonderful?
Yeah.
That's like -69.
So whatever that answer is, it would be in gallons per year.
Yep.
Okay. So that's a pretty simple one. It's not on your test though.
Why not? It's like 3 points.
I know, but it's not. Part B, the second part B, don't you love you have A, B, B? Okay, so second part B says, it will no longer be profitable to pump oil when there are fewer than 50,000 gallons remaining. In order not to lose money, at what time t should oil no longer be pumped from the well? So when should we stop pumping? Well, we want to know at what time does the y value equal 50,000. This is very similar to what's on your test. Your test is going to have a couple of these. They're 5 points each. One probably, I'm not saying for sure, but it's very likely. One where they give you an amount and you have to solve for t, and one where they give you a t value and you have to solve for the amount.
Ooh, if
Okay.
they're 5 points each, then that means they're probably not part of the multiple choice because they're probably part of the. Never mind.
This is all still part of the free response.
I was trying
Yes.
to depict what you were saying, like.
Yes, yes. So for this one, our y value is 50,000, so we have 50,000 equals 1 million.
Why are all the zeros connected? Is that just...
E to, that's just how I write zeros. 1/6 ln of a half times t. We have to solve this for t. What should we do first?
Divide by a million.
Divide by a million. 50,000 over a million, just 1/20th, equals e to the 1/6 ln of a half times t.
Not the log all that.
Natural log both sides. So we get ln of 1/20th equals 1/6 ln of a half times t.
Then write all that stuff below.
Yeah, you could divide by this whole thing. I'm going to times by 6, divide by ln of a half. So my t is 6 ln of 1/20th divided by ln of a half. And it didn't say anything about rounding, so you could leave your answer exact if you wanted to, or you could convert it to a decimal. If you convert to a decimal, how many places do you have to round to?
Sure.
At least 3.
3.
Sometimes converting to a decimal is nice because you can check to see if your answer makes sense. Okay? But it's not required for this one. If it said round to the nearest year, then you would have to.
If you did that over
Right.
26 years.
Okay. All right, so any questions on this?
I failed.
Everyone feel comfortable with this kind of a problem? Good, so that's a third of your test right there.
Damn.
Technically, it's like.
I've actually
missing
suddenly
the
a lot
other
more confident
5.
about this test.
Good.
From that third.
You still get a third.
Yeah, I gotta say, 2/3 of your test are very similar to your last quiz, and most of you did very well on it. So I have good, high hopes
You
for
feel bad about
these
it?
tests.
No, you
So 30 point questions.
Okay.
Yeah, but now that you understand what they are,
Now, we're gonna
let's do like
do,
30-point questions.
This slope field question for just a couple parts, and then I'm going to actually use a different slope field question for the other parts. So, we're on the same sheet, we're on the slope fields part. You know what was kind of surprising to me was how many of you lost points on your slope field sketch because you gave me more slopes than what was asked for.
Oops.
So, on the quiz it specifically said the 8 points indicated and there were 8 dots, and some of you just gave me like 15, 20 slopes. You just wrote slopes everywhere. You just went crazy with those slopes, right?
They put them on
So,
like 0.
yeah. So make sure you only put slopes where they're asked for. So in this case, there's 15 points indicated, and you see the 15 dots, that's where they want the slopes. Okay, this is also an AP exam question. We're getting into a point where all your free response now is going to be AP exam questions. Alright, so here we go. We're going to sketch a slope field. This is our differential equation, x squared times y minus 1. Notice that if x is 0, the slope is 0. So for all the spots where x equals 0, we can put slopes of 0. What does y have to be for the slope to be 0?
1.
Y is 1. Whenever y is 1, the slope is 0. Okay, so those are kind of like the freebies. Now we get into actual slopes. So when x is 1 and y is 2, we get 1 times 1, so we get a slope of 1.
Cool. When x is... Oh, we could just do the other side because it's squared.
Ooh, that is true. When x is negative 1 and y is 2, it's still a slope of 1 because it's squared.
How convenient.
Yeah. Now if x is 1 and y is 2, we get a slope of 2, so we need a steeper slope, and it's going to be the same here because x is being squared.
I feel like my slopes are just so icky. My slopes, like, your slopes are so neat. Is it just practice or is there like a trick?
I don't know. I think it's just practice.
I want to be as good as that one day.
That's something to work on. Practice, right? Yes.
Practice my slopes.
Okay, so here we go. X is 1 and y is 0. We get a slope of negative 1. It's going to be the same there. If x is 1 and y is negative 1, we get a slope of negative 2.
You know where you should go before you leave Georgia, Bryce?
Where?
You should go to Tom and Cheese. By Chuck and Cheese on North Point.
It's not good. I went there.
It's pretty good. If you get the grilled cheese donuts.
30 minutes to get one grilled cheese.
Well, I think maybe you just went on a bad day. If you go there and get the grilled cheese donut, I recommend it.
The grilled cheese donut.
Yeah,
actually
they take
pretty
a donut
good.
and they cut it in half and they invert it and they put like cheese in the middle. It's so good.
It's actually really good.
It sounds like a heart attack.
I think you're just trying to be. I think you're just being difficult.
Being negative?
Yeah. Don't be so negative.
Think about it that way.
You have to think
Is
of
it a donut shop?
No,
No, it's a grilled cheese shop.
It's a grilled cheese shop.
Gourmet grilled cheese and tomato soup.
Oh, that does sound good.
Yeah. Don't listen to Jennifer's pessimism.
Considering it took them 30 minutes to make one.
Jennifer, maybe it's because you were rude to them. Because you were treating them like this.
Okay, alright, let's get back to the review, but I will take that into consideration.
When you go and take your children to Chuck E. Cheese's.
There is a donut shop on the corner of like
Math and
Maine,
science.
yes, where Maine and Old Milton
Yeah, that's
intersect.
Donuts.
Which, yeah,
The little ones.
they have those little ones. They have one that's like
Bacon
a
on it?
bacon and
Yeah.
maple syrup, and it's
So good.
amazing.
Oh.
See, you would definitely love this grilled cheese.
Okay. Alright, so
You know,
anyway.
all the streets at her new place or her new town are like math and science.
They're all school subjects. There's art and gym. I
wish
live
had
on
gone to
English.
math.
So, anyway, okay. Quiet please. Now, very quickly, this little part, this was for this exam. While the slope field in part A is drawn at only 15 points, it is defined at every point in the xy plane. Describe all points for which the slopes are negative. Well, visually, you can kind of tell where the slopes are going to be negative. Anyone have a guess?
Below 0.
Um,
Or 0 and below on the y-axis.
what about it like a half? What do you think?
Y is less than
It's
1.
negative.
Oh, less than 1.
Y is less than 1. And the way you can know for sure is you can say, all right, well, algebraically, x squared times y minus 1 has to be less than 0, right? And x squared is always positive, so we just focus on the y minus 1 has to be less than 0, so y has to be less than 1. But everyone who put this on this AP exam lost a point.
Because it didn't forget the X.
Less
Can't-
than 1.
Yes. That's beautiful. That was awesome. Did you guys hear it?
No, X can't be 0.
You had to also state that x cannot equal 0. Because just because you're below y equals 1, you're not necessarily negative. If you're on the y-axis, you have a slope of 0. So you have to say y has to be less than 1 and x cannot equal 0 to get the full credit.
Is that on the test?
No.
Gotcha.
All right, let's quickly solve this differential equation, but we're not gonna do part D for this. We're gonna do a different one. But I like this differential equation. So here's what we have. We have dy dx equals x squared times y minus 1. 1 over y minus 1 dy equals x squared dx. Do I have to do a u substitution on the y minus 1?
No.
No, because it's y plus number, so it's ln. Do I need an absolute value?
No.
Yes.
Yeah.
Yes, I do.
Does that Y look square?
Antiderivative of x squared?
One third x
1/3
X
x
cubed.
cubed plus c. By the way, this relates to the joke. So, if you forget the antiderivative of x squared, it's in the joke. So, there you go.
Thank you.
Yeah.
Is it like the Bob joke that you thought was so funny?
No, this one's very different.
Okay, good.
All right. All right. So here we go. We've got this.
Shout out to Amber.
Shout out to Amber, except her name is Sydney. Yes.
No, it's not.
Okay.
I promise
So
you
anyway,
it's
here's
not.
what we
I've
have.
seen her birth
We have absolute y minus 1 equals e to the 1/3 x cubed plus c, which we're going to call a e to the 1/3 x cubed. How do I drop the absolute value?
Make it plus or
I
minus.
put a plus or minus on the other side, but since it can't be both, I'm just going to rewrite my constant as an m.
I'm assuming it's positive.
E to the 1/3 x cubed, and actually that's a very safe assumption, but e to the 1/3 x cubed plus 1. Alright, so we've got this. This would be our general solution, but now we need the solution that passes through the point 0, 3.
Well, it's obviously has to be positive.
So we plug in 3 equals m e to the 0 plus 1, so m equals 2. And we get y equals 2e to the 1/3 x cubed plus 1. All right, everyone okay with the differential equation and sketching the slope field?
I'm gonna go to Furman. I'm gonna like
That's good. Okay.
party really hard with her, and I'm gonna like get her like so she can't remember anything. I'm gonna take her.
Okay, are you guys done? Can I erase this?
To Amber Hutchinson. I'm just gonna wake up and like I'm gonna have gotten her like a new license and everything that'll all say Amber. She'll be so confused. She'll wake up being like, no, I promise you, my name's Sydney, and then like nobody will believe her because like all her birth certificate and everything was like Amber. It's gonna be awesome. It's gonna be like the best. And then oh, it's gonna be so great. I'm gonna like get her children to call her Amber too. I told the Hutchinsons they're gonna be invited and be allowed to sit front row to my wedding.
I don't. Yes, of course.
You see,
The next couple parts on your review were
You're from my family.
not as good as I would have liked because you get an equation of a tangent line just y equals 3, so anything you plug in would be 3 and it's just silly. So instead, I'm going to use this problem, which is from Mr. Yang's morning review that he likes to do before tests. So he likes to pre-plan the review that he's going to do. So this is his morning review for this test, and it says dy dx equals xy over 2. We're not gonna sketch it, we're not gonna solve it, we're just gonna jump right here and talk about tangent line equations.
Cool.
Okay, so we need to write an equation of a tangent line that passes through the point 1, 1. What two things do we need to write? We need a close.
Point and a slope.
We need a point and a slope, right? Okay,
Just
these
never
problems are really simple, they're real easy to overcomplicate. I'm going to raise this up and just rewrite the equation off to the side. So dy dx equals xy over 2.
The Nelson was so cute.
Apparently it was like 3 minutes. Watch it.
The good news about equations of tangent lines with differential equations is even if you totally messed up on solving the differential equation, you can still get the tangent line stuff perfect.
Oh, that's nice.
It is nice, I agree.
It was online. Same place we got this one from.
Okay, so dy dx equals xy over 2.
Yeah, well,
We need a point.
Hey, look, we have a point.
What is the point?
1, 1.
1, 1. It's given. It's right here.
What? Where'd that come from?
Now we need a slope. What do we use?
Whoa,
this
it's right
plus-
there.
Oh, dy dx means slope, right? That's the derivative, that's the slope. So you just plug your point into your dy dx formula.
So that'd be 1/2.
I assume so.
There's your point, there's your slope, write your equation. Y minus 1 equals 1/2 times x minus 1. And that's good enough, because that's an equation of the tangent line. Doesn't say you have to solve for y.
If
Yes?
you flip the y and the x.
On the previous problem, on number 2, I guess it was, D had us approximate for point 1. Are we gonna have to do that?
That's what we're about to do right here.
Awesome.
Yes, yes. So, good segue. All right, so we're going to use our equation of our tangent line to approximate the value of f of 1.2. When you have to do tangent line or linear approximation, the way that works, I dropped, there we go, is you just plug the value into your tangent line. So this is like our x value, so you get y minus 1 equals 1/2 times 1.2 minus 1. So y minus 1 equals 1/2 times 0.2. Y minus 1 equals half of 0.2 is 0.1. And then you add 1 to both sides and you get 1.1. That's your approximation. Alrighty.
That was too difficult.
So, that's another, I don't know how many points on your test, but that's some points. So, good to know. So to write your tangent line, you just use the point and the slope, and you write point slope form. And then to use it to approximate a value, you just plug that value into your tangent line equation and get your y value. Any questions on that? Good. The last thing we need to go over before we start talking about the multiple choice is we need to talk about how to find the domain of the solution to a differential equation.
Oh, I know this one.
Now, it was on your last quiz. I made it an extra credit because the one on your last quiz is a little tricky.
Just a little?
A little bit. A couple people got it.
I got a point. I only got 1 point though. It's kind of salty about it, not gonna lie.
A little salty about that 1 point.
Yeah.
Did you get it correct?
I don't think so.
Well,
I don't think I got it correct. Wait, test. Wait, there was a test in there. You should go check that out.
okay.
Well, that's a slight problem. I want to clean that up, dude.
All right, so I'm going to Okay. All right, so here's what we have.
I'm so so glad myself doesn't sit with us anymore. Such disruption to the class.
We had an equation, dy dx equals 1 over xy. And then we had a solution. There were different solutions based on which version you had. But for this one, the solution was y equals negative the square root of 2 absolute value x plus 16. There were different versions, but this was this one.
Okay.
All right, so we need to find the why am I thinking I'm missing an E? Is there an E in there that I'm missing? Who's got their quiz handy?
I guess like with the
I need a quiz that actually has. Oh, it's ln of absolute value x. Thank you. I knew there was an E in there. I remembered that E in the answer. I knew you needed ln. Okay, so it's 2 ln absolute x plus 16.
Oh, I got them flipped around, that's why.
Okay. So we have y equals negative square root 2 ln absolute x plus 16. All right, and the question is, state the domain of the solution. The domain of the solution has to, number 1, meet the requirements of the domain of the original differential equation. So based on the original differential equation, we know that x cannot equal 0 and y cannot equal 0. Because if either of those was 0, we would be dividing by 0.
That's bad.
Yes. So those two conditions have to be met. So based on this, our domain would be either negative infinity to 0 or 0 to infinity, but we don't know. Now we've got to find the domain of this, because you have to satisfy both domains, the domain of the original and the domain of the solution. This is where it gets fun. So we know for this to be true that 2 ln absolute x plus 16 has to be greater than or equal to 0. First problem is it can't be equal to 0. Because if it equaled 0, you'd get a y value of 0, and you can't have a y value of 0, because y cannot be 0. So this has to just be greater than 0. We have a nonlinear inequality to solve. When you have to solve a nonlinear inequality, you find your critical numbers and you make a sign line. So we have 2 ln absolute x plus 16 equals 0, because those would be our critical numbers. Ln absolute x equals negative 8. Absolute x is e to the negative 8, so x is plus or minus e to the negative 8. Now we make a sign line. We have negative e to the negative 8. We have positive e to the negative 8. And we also have a critical number of 0 because x cannot equal 0.
Alright, let's do this.
Let's do this. Okay, when you need to figure out signs for a natural log, you want to pick values that are powers of e. So if this is negative e to the negative 8, which is the same thing as negative 1 over e to the 8th, we could pick something like negative e to the negative 100th, and that would be way less, because it'd be, negative e to the, now I'm second guessing. Let's go with the positives first so that I don't freak myself out here. E to the negative 8, so 1 over e to the 8th. So we would want a power that's bigger, so smaller, bigger mathematically. So e to the 10th, right? So if we pick e to the 10th, just plugging in an e to the 10th here, because we know that that's way bigger than e to the negative 8th. So we plug in, we get natural log of e to the 10th is 10. 2 times 10 is 20 plus 16, that's super positive. Over here, let's do negative e to the 10th. Because that would be way more negative than negative e to the negative 8th. So if we do negative e to the 10th, well, the natural log of negative e to the 10th. Remember, it's the absolute value, so that negative gets dropped. It's the same as the natural log of e to the 10th, which is 10. 2 times 10 is 20, plus 16. We're positive over here.
Cool. Super positive.
Super positive. All right, let's go in between 0 and e to the negative 8th. Let's do, here's where your e to the negative 100th comes in. Because if this is 1 over e to the 8th, then 1 over e to the 100th would be much, much smaller. So if we plug in e to the negative 100th, the natural log of that would be negative 100. You'd have negative 200 plus 16. It's like super, super negative.
Super, super negative.
And then the negative of that, since it's an absolute value, this negative gets dropped and you end up having the same amount. So after all of our little checks on our sign line, and that's by far the hardest part of this, we end up with the following domain. So based on the solution, we have negative infinity to negative e to the negative 8th, union e to the negative 8th to infinity. But the domain of a solution of a differential equation can only be one interval. You have to pick one. How do you know which one to pick?
Which one the point's in?
It's which one the x value of the point is in, since we're talking domain. So which of these would contain an x value of negative 1?
The
One on the left. So our domain for this differential equation would be negative infinity to negative e to the negative 8th. This is harder than what's on your test.
Can you hypothetically give us what's on our test?
Not off the top of my head.
Can you like Google it for a little bit and then
You like-
hypothetically give it us?
After I shut the camera off, I'll see what I can find.
Thanks, Miss Price.
You're welcome. Okay, so let's talk multiple choice. Guys, don't freak out about the domain. That's not a huge part of the test. It's one little part of one question.
It's only worth like 36.
It's only worth, 42 points.
That's wonderful.
Oh,
It's only worth 90 points. Don't freak out.
And that'll mean the test will be more than 94 points.
here we go. Okay, let's talk integrals.
Are we gonna have to know how to do the number 16 on that one?
This one?
Yeah. Because it has like an identity and stuff, and it's kind of confusing.
You mean just cosine minus tangent squared?
It's a 1 minus cosine squared x.
This is, yeah, it's a different one. I wouldn't worry about that. There's nothing like
My
that.
question is why?
This one's on there though. Let's do secant 2x. Here's my maybe.
Why do all these problems look so rickety? They're all just like
Is this on the review we got?
Yes, this is on the multiple choice review you got. I made this review
it looks so ghetto.
years and years and years ago. Do you know, I actually did this by taking problems
And
out
cutting
of,
them out?
and literally with the scissors cutting them out and taping them to a piece of paper and photocopying them.
That's so ratchet.
No.
Oh my
It's
goodness.
so ghetto.
Okay, alright, so we
Miss
want
Price,
the
wait,
answer.
I don't know if I can do this. This is too ratchet for Milton.
To ratchet?
Ratchet? It means like too like
Ghetto.
too Roswell. Too
Roswell.
Too Roswell for Milton. You should probably send this over to a Roswell teacher and make it
South side.
That's what I'm saying. I don't know if Milton students can handle it. Oh, like it's not even. I don't even think that's like Times New Roman. Oh, that's like New Courier. I can't even stand it.
No,
right
that's
now.
Times New Roman.
I don't think it is.
It is.
I asked New Courier. Have you ever seen the New Courier font?
Are you, like, being,
Yeah.
how do I say this?
Serious?
What's the word about, like, not pompous, but over a font? I mean, you can't, you don't have to go there.
I don't know. I'm just saying. It's like people that
Okay.
use Comic Sans and
She's being
like.
a snob
reports.
right now.
If you're a font snob.
I'm not a font snob.
They
The font
say
sound black.
Comic Sans
Okay.
is the most hated font in existence, so actually it is.
So
My favorite
anyway,
font is like
to do this antiderivative, what would we have to do?
we'd have to know how to do it.
Okay, that's a good start.
Hey!
No, we'd have to do a U substitution. So what's your U gonna be?
2x.
So what's your DU?
That.
2dx, right? So what we get when we rewrite the integral, well, this becomes secant u. We need just dx though, so I have to divide. So 1/2 du equals dx. So dx is 1/2 du. So this is just the integral of 1/2 secant u. Of course, we have to know the integral of secant. Do you know the antiderivative of secant?
Isn't it like cosecant something cosine?
It's
I'll start you, it's ln,
Secant x plus
absolute value, plus c, and then we would rewrite the u's back in with 2x.
Those are some like very red rainbows.
That's a compliment.
Yeah,
I can go shopping too.
I don't think we're gonna have to right now.
I think that's my target right now.
remembering, are they coming back to you? Let's take a look at 21. Quiet please. If I rewrite 21, what's 1 over cosine the same as?
Secant, is that right?
What's 1 over cosine?
I was
Secant. What's sine over cosine? Tangent. Does this one require U substitution?
no.
No, you just have to write the answers. Hey, what's the antiderivative of secant?
Secant plus tan.
It's right up there.
Natural log,
That's
absolute value, secant theta
minus tangent
plus tan theta.
plus tan. I'm sorry.
Okay, now we have to find the antiderivative of tangent.
absolute value cosine theta.
Ooh, it's negative, so we're going to turn this into a positive ln absolute value cosine theta plus c.
When are we ever gonna
Hey!
I want to design fonts much better than
Okay. Make sure you learn the antiderivatives of your 6 trig functions, because 1 or more of them will be on your test and you're going to want to know them, right? Okay.
Here, this is my favorite.
Mrs. Price,
Yes.
can I request a problem?
Oh, absolutely.
You do number 12, like the absolute, where like they give you the limits, or not the limits, but like the numbers.
Perfectly, it covers
It's
all.
like trig or whatever, it's weird.
See,
This
this is the
one?
pattern. This is called the spooky font.
The definite
This one is
integral?
the I don't care.
The inverse
This
trig?
is just the perfect
Okay.
one.
Like I get how you like
And then
get to the part where you plug in the absolute the absolute things, but I don't know how you find like which, if it's like pi over 3 or negative pi over 3 or like 2 pi over, like all that.
I don't think there's any definite integral inverse trig on your test.
So like I don't know like which quadrant to like select it from and how to write that.
Whenever you're not sure, when you have an inverse trig problem and you have to plug in, you're always going to use your principal values. This one, hey guys, which function is this?
Arc sine.